so let's record and let's share my screen. Yeah. So I have both of Gerber's assignments. I have Travis Mead's assignments. So just let me know. So really what I wanted to do is just make sure you guys have best information you guys can have. So I use the Word document. Yeah, you can use Word documents. Yeah, you can use a Word document. You can also use what's called Overleaf. If you so Overleaf is this guy here. Don't worry about the subscription, but basically, for Overleaf, you would basically use like a blank project, give it a name. So I call this like test number one, and then this would use what is called LaTeX documents. So what you could write the code, and then you could download the PDF, and then boom, it'll generate that. So there's also this if you want to try Overleaf as well. No worries, not a problem. Do you have to pay for it? No, I don't think you have to pay for Overleaf. I haven't paid for this. Yeah, they have a free plan. I just use the basic ones. The basic one should suffice. And yeah. Oh, right. Um, right. In the mean. So the idea for this is just like if you guys want, you can come off mute if you need to. Or if you guys want, you can type it over text and I will do my best to help. So with that in mind, any questions that you all have for me? You don't here. Anything else I can think of? Not particularly. Let's see. For question three, how can you get R and Q into the same statement? Is this for Gerbers or is this for Meads? For Meads? Okay. So for this one, you're using I should edit this. Dang it. Okay, hold on. Let me edit that part. Give me 1 second. Edit that. Where is this thing? This thing. Let's edit it. Do. Um, what's that? All right, so it's oops, didn't need to do that. Oh, that's so awkward. Oh, so awkward. All right. So you're asking about this guy, right? So my hint to you is let's see, upload. Has he uploaded one? Please tell me he has uploaded something regarding that. Notes? No. Okay. Let's see here. Okay. So I guess this will do for a bit. Um, so what you want to do is we're asking you to use some sort of combination of laws of logic, which would be referring to um, these rules and these laws of logic in here. So in this PDF here, some combination of like, for example, the commutative law, double negation, associative, distributive, idempotent, et cetera, along with something called rules of inference, which I don't think we've gotten to yet. But uh, rules of inference are ways that we can infer how something happens. Um, and so these are the rules of inference here. So like the conjunctive simplification, um, would have the destructive amplification and stuff like that. You would need to use some combination of these rules of inference along with the laws of logic to help get to the fact that if we have not in parentheses P implies Q, along with the fact that you have P or R, we can conclude that not R or not Q happens. Does that make sense or not particularly? Because it's not just like laws of logic that you're trying to use. You're trying to use both um, a combination of laws of logic and you're trying to use rules of inference. Um, and the concepts. Yeah, uh, I would encourage you to try to use some rules of inference. It'll help a little bit. And if you want me to explain anything, just let me know. Any other questions you guys have for me? Mhm. Okay. Just want to know if you guys have any other questions, and I will do my best to answer them. let me know if you guys have any other questions. Yeah. Is this for Goobers or for Meads? Yeah, I can give some pointers. So we're taking a look at some of Mead stuff. So me just gave you guys I think 8 questions and some of the and then there's some practice ones if you guys have time. Um so we'll kind of just like I'll give some of my tips that I did when I was looking at them. So for the first one, we're going to assume the following. So P is going to be equivalent to the statement movies are fun. Q is going to be equivalent to this statement I like movies. And then R is going to be equivalent to the statement I like popcorn. And the question we have for you is that we want you to write out the following logic statements in terms of P, Q, and R using some combination of the implication sign, the disjunction sign, the conjunction sign, and the negation symbol, along with using P, Q, and R. So we gave you a variety of statements. What I would do is I would take a look at each of the connectives. So for example, let's look at like negation. What does negate? And I would ask like, what does negation represent in like the English language? So, what is the key word that you think of when you see negation? Not, right? So if you're looking for when to use the negation symbol, one of the keywords that should pop up in a sentence should be the word not. Likewise, when you see the conjunction symbol, what word should pop up? Exactly. And so you should be looking for those keywords and seeing what they are because that those keywords are going to help you to identify what connective to use. And then you're going to look for the topics that need to be covered. So popcorn is going to be covered by R, movies is going to be covered by Q, and the fact that movies are fun is covered by P. And so that's like how I would go about doing that. Does that make sense? So far, so good. All right. Um, so number two, we're asking you to prove the domination laws by using a truth table. Um, and when we say domination laws, we're referring to the fact that this guy right here, this guy's a tautology. The fact that the tautology is equivalent to tautology or P, and then we also want you to show the other version. The contradiction, or the big F symbol, is the contradiction conjunction P. You can use either one or two truth tables to do so. So keep in mind what a truth table is. Do you guys remember how to do a truth table? It's okay if you don't. No worries. Perfect. So remember, keep in mind you need to identify both rows and columns. Uh, Yep, the number of rows is going to be equal to two, not two to the number of simple propositions. The number of rows is equal to two raised to the number of how many variables there are. Yes, it should only have two rows because there's only one variable that you're working with. That variable being p. And the number of columns is determined by the number of simple propositions that are in your statement. So in this, I have one proposition, which is tautology. I have another proposition that says tautology disjunction P. And then you can also have a contradiction by itself. and then you can have contradiction and P. And then you would prove that. And a hint that you did it correctly is that the column for tautology and the column for tautology or P should be exactly the same. And the same thing here for contradiction or and P. These two columns should be the same. Does that make sense? So far, so good on that part right there. Cool. All right. So number 3 is when we start getting into a little bit more of the deeper end. So number 3 is going to be a proof kind of question. The true value of tautology is always true. Yep. Tautology is a statement that always resolves to the true value, whereas contradiction will resolve to the false contradiction value. All right. Does that make sense? Perfect. All right. So for number 3 in Beats class, you have to use laws of logic or rules of inference or some combination of them to prove that the following argument. We want you to list each rule and proposition used for each step, and we say that note you will need to have derive more statements than listed. Okay, so we tell you that the first statement is so we have first statement is negation, and then the statement in parentheses is P implies Q. The second statement is P or R, and we want you to conclude that not R or Q is true. Okay. Oh yeah, no worries. I can go over it after I finish. I can go over Gerber's things after these things. I'll do that part. No worries. Yeah. So for number 3, you want to be I wish he uploaded it. I'll probably you know what, actually let's get that done. So what I'm gonna do, and Gerber's class already has this, so really I'm just going to go kidnap one of these folder sheets. All right. Take this, let's download that. And then let's put you let's put this formula sheets. That's that. Just rename this version 1. All right, so what I would encourage you to do if you're in Meets class or if you're in Gerber's class, regardless of which class you are, when we give you, if a question is along the lines of prove this, I would encourage you guys to look at a formula sheet. These formula sheets will tell you exactly how each law of logic / rule of inference works. So when we're talking about laws of logic, we're talking about double negation, De Morgan's, the commutative, the associative, distributive, idempotent, identity, inverse, domination, absorption, and the implication identity. Contrapositive is a law of logic technically, but we're going to kind of ignore that one for a bit. But some combination of those laws of logic, along with some combination of these using these rules of inference. So modest ponens, syllogism, modest tollens, conjunction, disjunctive syllogism, conjunctive simplification, amplification. I really kind of ignore contradiction and conditional proof for now. I ignore cases as well. And then if it comes to it, the constructive and the destructive dilemma. Some combinations of these laws of logic and rules of inference are going to allow you to derive this. Keep in mind a couple of things. One, you have to assume that these first 2 statements are true because these are your jumping off points. You must assume that they are true. Otherwise, we don't have anywhere to like start our argument. And 2, we don't want you to be using truth tables. No truth tables past like question 2, essentially. The other, and one more thing, you want to make a table of some sort that has two columns. The first column should have your numbered statements. You should number all your statements. And then the second statement should the second column should have your reasoning. So like, how did you get a statement? So for example, what law of logic / rule of inference did you use? Does that make sense? Or do you want me to show you like some like a outline of that part? Okie dokie. Any questions on that part? Any questions on number 3, or is there still a little bit of confusion?
Hi, I'm sorry. Could you please show us an outline or a linked one in the
Yeah. All right.
chat?
So
Thank
mhm,
you.
yeah, no way. So let's do this. All right. Where is my print screen? There you are. Okay. Shit, this is not gonna work. Fuck. Um, okay, there we go. So let's take this guy, and what I'm gonna do, I'm being incredibly lazy because I don't want to type all this out. It hurts my brain to do it. Um, but essentially, if you're doing it, whether you're doing it on Word or Overleaf, the idea is that you need to make a table that has two columns. I'm just gonna make this since I'm doing this on Word for now. I'll just make this a table here. And then you're gonna have two columns. And then what I'm gonna do is the first column is going to have like the numbered statement, and then you'll have like some sort of reasoning on the second column. And then what I would say is proof for formality. So for example, I could say that like, and then, so for example, let's see this. So for example, what I could say is I could put these first two steps here. So I could say that this is the first statement is not P implies Q. And then my reasoning for this would be because this is my assumption / given / premise / hypothesis, whichever one suits you both. I personally do assumption / given, but all four of those would work. And then the second reason, second statement, I would put like P or R. Where, and again, this is my assumption / given / premise / hypothesis. And then you would have a bunch of statements here. So like, well, like you would give me a number statement for 3, 4, and then dot 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 all the way until you get the final step, which is therefore not R or not Q. And this is by some reasoning. Does that make sense?
That's perfect. Thank you.
Mm-hmm. Yep. And again, don't there are multiple ways to do this proof. We technically don't care how you do the proof. All we ask of you is that the reasoning is logically sound. So as long as there's no major gaps in it, it should work. All right. Does that make sense for that question? Yeah, step 2 would be given. You don't, yeah, step 1 and step 2 are given to us because notice that this line above, anything above this line is technically given. So you don't have to say like, oh, like how did this come to be? It's because that's where our jumping off point is. That's called our reasoning. Yep. All right, can I explain how conjunctive simplification works and disjunctive amplification? I absolutely can. So this is actually going into a deeper understanding of laws of logic than rules of inference because this is part of what we call rules of inference. But let's talk about it. So rules of inference. We'll just start with this. So conjunctive simplification. Uh, I'll phrase this in an English sentence way, and let's see if it makes sense. So let's say we know the fact that the sky is blue, and we are UCF students. Nothing too crazy, right? So let's assume that we know that the sky is blue and the fact that we are UCF students. So far, so good on that? All right. So if we know that if we know that the sky is blue and we are UCF students, what else can we conclude? What can we conclude if we know that the sky is blue and the fact that we are UCF students? Yeah, every individual proposition has to be true on its own. Yeah, we can say that the sky is blue, and we can also say that we are UCF students. And essentially, that's conjunctive simplification right there. That's essentially in action. If you have two propositions, P and Q, we can infer that P happens, or if we have P and Q, we can also infer that Q happens. It's almost like chopping off each of the individual events on its own. Does that make sense? But super important. Note that I am only going in one direction. For example, if I know that I am a UCF student, I cannot conclude that I am a UCF student and the sky is blue. Because what happens if the sky turns out to not be blue? Then that's a problem. Does that make sense? Cool. All right, so that's conjunctive simplification. Disjunctive amplification. I call this the magic rule. Let's call this the magic rule. So and again in English, right? So let's say I know that I am a UCF student again. So does it, so can I say the fact that I am a UCF student, or I am a reincarnation of God? Because why not? I don't know. I'm a narcissist. And have the statement be true. So can I say the fact that I am a UCF student or I am a reincarnation of God and still have the statement to be true? Technically, yes. Yeah, technically, yes. I can say this and the statement is true because it doesn't matter whether or not I am a reincarnation of God. Does that make sense? Because I already know that the first part of the statement is satisfied because I know I'm already a UCF student. So if I already know I'm a UCF student, the second half is not technically needed. I'm just adding events that could happen, but it doesn't impact the truth value of the original statement. Does that make sense? So when we write it formally, we can say that P implies P or Q. Does that make sense? So the idea is with amplification, you can essentially create any event you want by adding a disjunction onto the original event. Make sense? So far, so good. Any questions on how that explanation for simplification and amplification works? Right, so that's simplification and that's amplification. And then this is a kind of like a structure that I typically do when I'm doing proofs. So yeah, no worries. So again, for number 3, you just need 2 columns, number statement, reasoning. You have all your statements on one side, you're going to have all your reasoning on the other side, and ultimately what I'll be looking for and what Travis will be looking for as well is how did you get to this conclusion of not R or not Q. Make sense? Sweet, sweet, sweet. Okay. So for that's the first 3 questions. Number 4, it's literally the same thing. You're just going to follow same idea. You just have a different givens and a different ending point. And this time we're going to give you a hint. So this time you want to make sure that you derive the big F symbol. This big F symbol is a contradiction. So what I would recommend you guys do is look at your formula sheet and find out how you can derive contradictions, and you can go from there. Does that make sense? So far, so good on the first 4 questions. Cool. All right, cool. All right. For number 5, you want to disprove the following argument using a counterexample. So, just like we mentioned in class, to disprove an argument using the counterexample, you want to make sure in this case, because well, actually, for this one, I'll kind of have to write this out for a bit. For this guy, I'll give you guys a kind of like jumping off point. So so another way to write this, we can write this in the following way. This is a little bit disgusting, but we'll make it work. So another way to write this is that we have R implies Q, and the fact that Q implies P, and the fact that S implies P. And this entire statement here is one big statement. All of this implies that R or S is true. And what we're asking you to do is to disprove this argument. So if essentially, think of what I want you to imagine is if we are trying to disprove this, we are trying to make sure that this statement here evaluates the false. How do we make an implication sign false? What is the way that we can make an implication evaluate the false? One way we can think about it is, so if we're trying to evaluate the statement to be false, remember that there's only one way. Keep in mind that there's only one way for an implication sign to evaluate to false. And that's when the left-hand side evaluates to true and the right-hand side evaluates to false. And so really what we're going to ask you is you need to assign or come up with a scenario scenario where this left-hand side evaluates to true, and then this right-hand side is going to evaluate to false. And the way you do that evaluation is you're going to assign truth values to every single variable. So is R true? Is R false? What about P? What about Q? And finally, what about S? Does that make sense? So we wouldn't, no, you don't have to use any laws of logic, no rules of inference here. You could try to do a truth table. I would recommend you don't use a truth table. It might be a while before you find it. I would just like break this up into like the left-hand side, which is essentially like this whole statement, and then the right-hand side, which is that statement. And then I would just start plugging in truth values and see what happens. Does that make more sense? Any questions so far? And then, all right, so, and we haven't gone to 7 or 8 yet. 7 and 8 are a little bit ways away. I would say probably next week we'll get into it. So I won't worry too much about it. So for now, what I would recommend you guys doing the scene if you can't do the first 6. The last one is just you're identifying any problems that this proof has. So what I would say is basically where does the first error occur in this proof? So in this proof, where does this individual screw up the first time? So yeah, that's basically your first homework. I would put off 7 and 8 for at least until next Tuesday. Hopefully we'll get there. If not next Tuesday, next Thursday. Because this stuff is pretty far into Unit 1, so don't worry don't worry too much about that. But yeah, that's basically Meet's homework. Any questions on Meet's homework? Okie dokie. All right, and now for Gerber's homework. All right, now for Gerber. Gerber's class is a little bit different, but nevertheless still pretty similar. Not past 6, not past question 6. Because this stuff here is really far into the propositions unit, so don't want you guys to be drowning in the deep end. I just kind of want you guys over here past 6, and then I'll let you guys know once you have, in theory, enough information to do questions 7 and 8. At the point that we are at right now for each class, I would honestly say you can probably go up to 2. 3 and 4 are kind of stretching it. You can probably do 5, but it's a real big stretch. Only reason why I say I hesitate on 3 and 4 is because rules of inference are going to be kind of needed for this. So unfortunately, he hasn't given you enough tools yet to finish those questions. All right. So as for Gerber's class, it is very much similar to Mead's stuff, just broken down into like different sections. So his first thing is truth tables. So you just need to create truth tables for the following expressions, include all necessary negations and sub-expressions. So basically, just like the truth tables that we had in Mead's homework, you need to identify how many rows you have, how many columns you're going to have. Keep in mind that rows are determined by how many variables you're going to have. Specifically, 2 to the number of variables will determine how many rows you'll have, and the number of simple propositions, quote unquote simple. That's basically how many different propositions can you find in your statement. That'll determine how many columns that you're going to have. So for example, this guy right here, number for this first part in problem 1, P, Q, and R, how many different variables are there for this problem, for that question? So if we take a look here, so if we kind of just count this, there's P, Q, and then R. So there's 3 different variables that we have. So that tells me that there are going to be 2 to the power of 3 or 8 rows in this truth table. And then we're going to have, there's going to be 1, 2, 3. There's 3 simple propositions right off the bat. P and Q is a 4th proposition, and then the whole statement should, there's a 5th proposition here, which is not R, and then the 6th proposition would be the whole thing. So that tells me 8 rows and 6 columns for this first guy. And then you can do that same logic applies basically to everything. So that's the first problem. Pretty much in a nutshell, you're just identifying how many variables, how many simple propositions, and then just filling out set truth table for problem 1. Does that make sense for Gerber's problem 1? Cool. Okay. For question 2, you're using is there a sheet with all the symbols? For Gerber, there should be. Meets kind of look like oh, the symbols. Wait, symbols. Not off the top of my head. I will try to make one off the top. I will try to make one in a bit. And upload it. Yeah, I'll make a sheet with all the symbols that we probably will use. Okay. So problem 2 is Boolean algebraic laws. Use Boolean algebraic laws to prove the following equivalencies. So we have 2 proofs. So essentially you have 2 proofs that you got to do here. When he's saying Boolean algebraic laws, he's basically referring to these laws of logic and rules of inference here. One thing I want you to keep in mind though, note that this is a by implication sign. And by implication means it needs to go in both directions. So if we have this statement here, we should be able to get to this statement. And if we have the left statement, we should be able to get to the right statement. So keep that in mind. I'll let you determine why that's important that it's an equivalent or by implication. But you're essentially going to use either laws of logic or rules of inference to do that proof. Any questions so far on Gerber's homework? So far, so good? Or... Perfect. Question 3 is a disproof. So to disprove a conjecture, you only need to find one case or counterexample where it is not true. And so we're saying to disprove that disprove this following argument. Again, keep in mind that this is a by implication. So remember what it means to be a by implication. And just like last time, where I was talking about in Meets homework, you're essentially just putting in truth values to each of them. You're going to put in truth values for P, Q, and R. And the idea is that you need to make this by implication evaluate to false. So keep in mind how to make a by implication evaluate to false. If you're unsure of how that happens, what my recommendation is to draw out a truth table for that. And what I would also say is that we can, if you have this guy here, that if you have that P, by implication R, that is the same thing as saying P implies R and R implies P. This is another way to write out the by implication. It's just by having that P implies R and the fact that R should imply P. So yeah, that's question 3. Any questions so far on this? Like any questions that you guys have for this that I covered? Cool. Would I mind going over what we would need to do for question 2? Like this guy right here? Kind of like this one here? Yeah. So for question 2, all you need to do is, given that you're starting, you're gonna use Boolean algebra. Don't use truth tables for this. A general rule of thumb is, unless we tell you otherwise, probably not a good idea to use truth tables for proofs because they're just really inefficient and they would take too long. So with this, what I would say is you would start on essentially either side and then try to get to the other side. So either start on the left side and get to the right side, or start on the right side and then get to the left side. What I would tell you to look out for is look out for what's connecting these two parts together. Keep in mind that this is a by implication sign. Again, a by implication sign means that you need to have the first event imply the second event, and you need to have the second event imply the first event. So keep that in mind. I would look up what it means to be a by implication and how it could relate to some other symbol, because there's another symbol that you can replace this with, and it'll make it a little bit easier. Don't use the plus signs and stuff like that. Keep it in the regular connectives. When we say Boolean algebra, we want you to be using like these laws of logic, rules of inference kind of thing. Don't use like actual Boolean algebra. A, because Boolean algebra fucking sucks. B, makes it a lot easier to read. Because having to do these pluses and the primes and all that, not a fun ordeal. Yeah, no worries. Let me pull up Gerber's thing because I kind of like don't want to lose out the button part. Files. So when Gerber is referring to his Boolean algebra laws, we are referring to these guys. The transformative logic in sets, the reductive logic in sets, and if needed, any rules of inference. And my only hint is to, well, my one hint that I want to give, I will give out, and I'll keep emphasizing it, is watch out for this by implication. Will it just utilize the entire formula sheet or just the logic and sets? Should just be using logics and sets and some rules of inference. All this stuff is that's a later issue. Let's call it a later issue. Let's call that a later issue. Make sense? Yeah, no worries. So that's question 2. Same for both questions. Watch out for this by implication. See if you can find another symbol that can replace it to make it a little bit clearer on what it means to be a by implication. And then start on one side, get to the other, and use lots of use the transformative and reductive laws of logic and any rules of inference needed. So yeah, that's your Boolean algebraic laws question. For number 3, it was just basically, again, watch out for the by implication sign, find a symbol that can represent a by implication. And then just like how I explained in question 5 here, you're going to need to come up with a counter example where this is not a true statement. So you want to know, we want to make sure we know how to evaluate when a by implication is false. So if we take a look at our thing, let's hope that Gerber is nice enough to have it. He is. There are certain ways that we can have P implied by implication Q to be evaluate the false. Could have either true false or false true. So either the one side has to be true and the other side has to be false, or vice versa. So keep that in mind as you do that disproof. Question 4 and question 5 are going to test you on your rules of inference and laws of logic as well as needed. They are both the same thing, just different verbiage. For question 4, you are given essentially a word problem. So assuming that the following premises are true, which are as follows, it is the first statement is that if it does not rain or it is not foggy, and then the sailing race will be held and the life-saving demonstration will go on. If the sailing race is held, then the trophy will be awarded, and then we can conclude and then assume that the trophy was not awarded, and we want you to conclude that it rained. So we want you to use your laws of logic and rules of inference as needed to prove to us that given all those premises are true, how do we get to the fact that it rained? My hint to you is to find ways to have variables represent certain topics or ideas, because this is a mouthful to read and type out. So having, for example, like P be the fact that the trophy was awarded, you can say P is equivalent to the trophy will be awarded or something like that. So every time you see the trophy will be awarded, you could say P. Just basically finding shorthand ways to write this in short sentences rather than having to write this in long ass sentences will save you both brain power and time. Other than that, it's just use your laws of logic and rules of inference, both transformative and reductive. Same thing with number 5, except this time instead of a story, you're just given a bunch of symbols. So with question 5, you're accepting the following premises, assuming that you have P and T in parentheses implies R or S, along with the fact that Q implies the quantity U and T, along with U implying P and this the statement not S. We want you to conclude that Q can imply R. Again, using your laws of logic and your rules of inference. So yeah, both of these are pretty challenging in my opinion, but they are a good jump off point for this class. Any questions you guys have for me in terms of that? For Gerber's class, I would say probably the best, you could probably do 1 and 2 and maybe 3. 4 and 5 might be a little bit harder to do because that one, those require a little bit more brain power to think. But other than that, pretty much was the homework that we have for both classes. Any questions you guys have for me?
I have a question.
What's up?
When we're referencing an inference, do you just want us to just copy it as it's written, or do you want us to like identify it, if that makes sense?
Are you asking like, so like, let's say are you saying like I use a rule of inference? Do you want us to like write out the reasoning and stuff like that?
Yes.
Yeah. Every
Okay.
time you write a statement, you need a reason why to say it.
Okay.
Here's the general rule of thumb. Intro to discrete is basically like a 5-year-old asking why in the car ride. That's basically the rule of thumb. So basically, if you tell me a statement, I'll be that 5-year-old kid and I'll always ask you why. And you have to answer a reason why.
Okay.
Does that make more sense?
Yes, thank you.
Yep, no worries. Any other questions you guys have for me?
So, do you do the homework like on the sheet given, or is it on like a separate sheet, like
So
on Overleaf?
I I do all my stuff on Word. I found a way to have all these symbols that I need on Word. If you do it on Overleaf, all the brains to you could never get it to work. In my 2 or 3 years of doing TAing for this class, along with me taking this class, I could never figure out how to do it. For Travis's class, he's kind enough to give you the where is this bastard? Fuck. Damn it, come back here, Travis's thing. He's kind enough to give you the LaTeX file that he uses to generate it. So what you can do is if you're planning to do LaTeX, I would take his LaTeX file. So his LaTeX file is always going to be this guy right here, the whatever the .text file. Download this and then just copy it into your project in Overleaf.
And then just work based on that.
Yep.
All right.
Using commands and stuff like that. He also left you guys some comments like, hey, make sure you use his title. You need to begin the problems. Here's where the first question starts. How to make a table. How to like do the dollar signs and stuff like that. It's just basically another coding language. Nothing too crazy. I think I just am lazy more than anything.
Yeah. How did you get it to like indent when you copied it in? Because mine just like
does it not indent automatically?
It didn't for me. I don't know why. I keep trying, but I can't get it to.
Let me download this. Okay, so overleaf.com.
Again, I copy pasted it in because so that might be it. I don't know.
Homework. So what I would do is upload the text, upload, select from my computer. So what I would do is upload my documents.
Okay, yeah, that worked. All right.
Yeah.
Thank you.
Yep, no worries. Boom, and now you can do all your stuff. Just make sure that when you do your main text, because when you have this main text here, it's always going to default to homework 1, like your initial title page. If you want the your thing to pop up, you need to have a input command. So you need to do \input, and then you need to input whatever form you have. So for me, I would just input this guy right here. Does that make sense?
Yeah, so just input your homework file.
Yeah, as the main thing, as like the main thing. Do it before you end of the document because otherwise it becomes really awkward. So input, and then see how it tells me which file do you want to do. It'll automatically search for your stuff that you have. So for me, let's do homework 1. Now it compiles. Boom. Now all of a sudden there's all the stuff in here. Make sense?
Yep.
There you go. That's how we do it on Overleaf. Do you find that the best way to study for this class is by practicing problems and using past exams, or are there any methods or resources you recommend? I recommend practice problems. I recommend past exams. Guha also has some nice stuff. But the biggest thing, and I know Kendall is here, so hi Kendall. The biggest thing, and I'm sure Kendall can back me up on this, study groups and office hours. This class is not meant to be easy. If you find yourself struggling in this class, that means you're doing a good job, because this shit is hard, to be quite frank. This is a very hard class. There's many reasons why me and Kendall made the Discord. But one of the very big reasons is so you guys can find the study group with each other. And you can contact us because at the end of the day, this class is not meant to be done alone. Not a lot of stuff in real life is meant to be done alone. So we want you to get into that habit of asking for help and asking questions, but also coming in with an open mind, essentially. And just like repetition after that. Also, asking the professors for help doesn't hurt, assuming that they're not dickheads and shoo you away first chance they get. But yeah, that's how I did it. It's just I found I found some friends in my class, and we basically trauma bonded over this shit. And yeah, that's basically how I got past this class. Yeah, always. I know that is probably not the best thing to give recommendations to, but fuck it. It's good enough for an explanation. But yeah, in all seriousness, I recommend finding a study group of some sort. I will be next week. I know I'll start hosting office hours, which I'll open up to everybody. I'll also be doing if you guys need it, put the announcement out. I'll do like some tutoring sessions if you need like one-on-one tutoring sessions or stuff like that. Yeah, I'll try to give you guys as much resources as humanly possible. All that me and the other TAs and the professors ask of you, come in with an open mind. Just come in, and yes, it's going to be hard, but trust us. At the end of the day, I'm going to say most. I'm not sure about all of us, but most of us want to see you pass this class because it's a tough class. It's a very tough class. Any other questions you guys have for me?
Do you know how to put something on a new line in the text, or are you just like strictly Word?
On like a new line?
Yeah, just like if I'm gonna go under like number one under the
Try doing a
I
double.
don't like
Do double backslash.
double stuff. All right.
Yeah, should double backslash should be the way. I want to double check this. Yeah, it should be a double backslash.
Yeah, that worked. All right, thank you.
Any other questions you guys have for me? Already. I will upload this to YouTube. I'll send the link out as fast as I can. I'll also be working on some basic materials for Unit 1, just like as a quick refresher if you guys need it. I know I promised Mead section that I would make some truth tables for every symbol. I know some students also have asked me about all the symbols that we need. I'll put that out there and how I write them out on Word, and I'll find the overleaf, the LaTeX commands, and then I'll push that out tonight. And yeah, I'll try to make sure that everything gets done quick, fast, in a hurry. And if you guys have any questions, feel free to ask me, and just let me know if you guys need any help. Until the next one, guys.